Hello and welcome to this lesson on event listeners. We will cover how to intercept user events like clicks or more complex touch events. We'll also take a closer look and implement some of these elements in a demo Android application. Event listeners in Android are interfaces in the View class that contain a callback method. This callback method is called by the Android framework when a user interacts with a view with a registered event listener. The Android framework will then call the callback method in the registered interface. These callbacks can be used, for instance, in these two examples below. One, when a user clicks an item in a list, and we need to open a new dialog to present the user with possible actions on this item. And the second, if a user wants to perform an action on multiple items at once, we can add an event listener for a long click. Then when the user performs a long click on an item, we can present a multi-select menu in the app bar. There are a wide variety of event callback listener interfaces available to detect actions on designated views. These callback methods can be attached to views in runtime and sometimes preset in XML for a view, as we saw in the last lesson when predefining an onClick callback for a button. The onClick that was added as an attribute to the button XML created a view onClick listener and attached it to the button. Once the listener was attached, it received a callback from the Android framework when the button was clicked. In a similar fashion, a view on long click listener can be attached to a view to receive callbacks when a view is long clicked or held by the user. In more complex UI screens, there may be many views presented to the user, and it's sometimes important to manipulate the UI based on where the user's focus is directed. A class that implements the view onFocusChangeListener interface will receive callbacks for any view that has the listener attached when the user either navigates onto or away from that view. Some Android devices have hardware keyboards built in, and this allows for listening to a special type of event for when a key is pressed. When a view attaches a listener for a class that implements the view onKeyListener, the class will receive callbacks when focus is on the view and a hardware key is pressed or released. For some user interfaces and applications like games or drawing applications, it is not sufficient to just know what the user has clicked or touched, but we need to know the specifics of the touch gesture or action. In cases like this, we can create a class that implements the view onTouchListener, which has a callback method that returns a motion event object. The motion event objects describe movements in terms of an action code and a set of access values. This additional information can be necessary for determining more complex user interactions than simple clicks. Sometimes a click is not enough to determine the desired user action. In cases like this, a context menu can be shown after a long click event so that the user can pick their desired action. In these cases, if a view has attached a class that implements the view onCreateContextMenuListener, the class will receive a callback when the context menu is being built. Now let's look at some of those event listeners in action. We've started a new project called Listeners with a main activity that loads a main activity XML. We also already added some views to our main activity XML, so let's take a look at that now. In our activity main.xml, we see we have a simple edit text and two buttons, one below and aligned to the left, and one below and aligned to the right. In this application, the user will be able to enter text in the edit text and either clear the entered text or show it as a toast. Let's take a closer look at the XML to see how this view is implemented. The views are housed inside a relative layout, so that we can position them relatively to each other. If we take a closer look, we see that the relative already has some default paddings set when we created the project. We'll get more into paddings and margins in a future lesson. The first view is the edit text. Note that the width is set to match parent, so we'll take up the full width of the parent, in this case an activity. The height is set to wrap content, so I will only take up as much height as it needs to display its text. We give the edit text an ID so that we can access it later in the Java code. Please note that the naming convention for our IDs in this lesson, the edit text starts with ET to denote edit text, and similarly all the button IDs start with BTN to denote a button. We will find that these naming conventions allow for quicker and easier access to these elements when binding them in Java code. Also, this edit text has the hint attribute defined. The hint attribute will set hint text that will be displayed when the edit text is empty. This is a convenient way of informing the user what the purpose of the text field is without having to use extraneous labels or other identifiers. Our first button is the clear button, and we can see that it has text from our strings.xml. If we press the control button and click on the text attribute, we can quickly jump to our strings.xml and see the values for this string. This button is also set to be aligned left and below our text view. The second button is our button to toast. We see that it has been set to be below our text view and aligned to the right. Now let's jump to our Java code. We can see that we have declared private members for this activity for our edit text and our two buttons. Also, there are two other listener class members, which we will get to shortly. Firstly, in our onCreate, we bind our edit text and our two buttons to their implementations from our XML. Here we see how the prefix naming convention can assist us when trying to write the code for binding the values. We notice that we have also set an onClick listener for our text view, but not for the buttons. This will mean that on the start of the application, the buttons will have no onClick callbacks, so if we click them, nothing should happen. However, if we click our text view, we'll get a callback to our new instance of text onClick listener. Again, we can press Ctrl and click and drill down into that class. We see that this inline defined private class implements view onClick listener and overrides its onClick function. Once the user clicks on the edit text, we will initiate the onClick listeners for both the buttons. So they will be disabled until the user clicks the edit text. We see that we set an onClick listener and an onLongClick listener to each button. First, let's take a look at the onClick listener. Let's note that we initiate our member listener button in this callback, and then set the same instance of the button onClick listener to both buttons. That means that no matter what button we press, we'll arrive at the same callback. Let's take a look at it now. In the button onClick listener onClick callback, we receive a parameter view v, which is the view that was clicked. We can use this to easily identify which button was pressed and act accordingly. We can grab the ID from the view and compare it to the button clear or the button toast. If button clear is pressed, we will set the text for our text view to an empty string. However, if button toast is pressed, we will create a toast with the content of the edit text. Now let's take a look at our button hint onLongClick we set for both buttons previously. First, let's note that our button hint onLongClick implementation implements the view onLongClick listener interface, and that its callback onLongClick has a returned Boolean value. This Boolean will determine whether the callback should consume the event or not. For instance, if we return true, it will consume the event, and our onClick will not be called for that button. However, if we return false, then both the onLongClick and onClick will be called. In this callback, we also determine which button was clicked, and then we will grab a string from our strings.xml and show it in a toast. Getting strings from our strings.xml is almost as easy in Java as it is to assign them in our XML. In our Java code, we need to simply call the method getString on our context and give it the identifier for the string, which starts with the prefix r.string. Now let's run the application on our emulator. Since we have not yet set the onClick listeners for our buttons, we can click them and long click them, and nothing will happen. Now once we click our edit text, we will set the onClick and onLongClick listeners for the buttons. and we can see that the hints are presented once we long click on the buttons. Now let's enter some text. And if we click the Toast button, we see that Toast is presented with that text. Then we can click the Clear button, and the text will be cleared. Thank you for joining us in this lesson on Event Listeners. In our next lesson, we'll take a look at margins, padding, and gravity in Android views.